Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. So far, we've learned about all the components required to build a touchless COVID safe entryway. Let's put all this learning together and build the project. Let me first do a quick recap on what we need to do. The doorbell will be touchless. When a visitor comes to the entryway, he will see an IR obstacle sensor. He just needs to show his hand in front of it from a distance. The doorbell will ring. The front door light is turned on as well as turned off automatically based on the ambient light conditions. We will write the current state of the light and the doorbell to Firebase. We will also provide a manual override to manually turn on or turn off the light if necessary. This manual operation will be done remotely through the cloud. Let's first design the system. We need an IR obstacle sensor which can detect obstacles in front of it. When an obstacle is detected, for example, when the visitor shows his hands in front of the sensor, it has to raise an interrupt. In the interrupt handler, we will have to turn on the doorbell. For the sake of this tutorial, we will use a buzzer to substitute the doorbell. The next requirement is to automate the light at the entrance. First thing we need to check is whether there's a manual override for the light. For this, we will check the cloud database for an entry called mode. The mode could take one of these values: A. Auto, B. Force on, and C. Force off. If the value is set to auto, then check the ambient light level. If the light level is low, we'll turn on a light. If not, we'll turn off the light. If the value is set to force on or force off, then we'll forcibly turn on or turn off the light. In this case, we'll not even check for the ambient light. We will also write the light state and the doorbell state to the Firebase cloud database. Now let's write code for this design. Instead of typing the code in the screen video, I will open the code which I've already written. I recommend that you use the screen video only as a reference and write the code on your own. However, for some reason if you want to download the full code, then you may do it from https github thingsping learn by making tree master pico projects and touchlessentryway.py. The whole URL is shown here in the screen. Now let's look at the code. As usual, the code starts with the import statements for all the modules that we need. I have then defined variables for various entities like IR sensor, LED, relay 1, relay 2, buzzer and LDR. Note that we only use relay 1 for the light. I've just used relay 2 here. If you want to, you could also connect a real doorbell to relay 2 and use that along with the buzzer. I have one variable for the Wi-Fi cloud module. After initializing this variable, I connect the module to the Wi-Fi router and configure the real-time database to be Firebase. The two variables BZ start time and FB reported are flag variables. I have added these to make sure that the ISR for IR sensor does not take too much time. The mode variable decides the mode in which the light will operate. That is auto, force on or force off. Let's now see what's in the IRQ handler for the IR sensor. If the IRQ handler is called, then it simply does the following. Turns on the buzzer, sets the FP reported variable to false, and sets the BZ start time to the current time in milliseconds. In this case, we've used the UTime module instead of the time module. UTime module is more specific to microcontrollers. The tix_ms method gives the number of milliseconds that have elapsed since the microcontroller started. In the while true block, I will use these two flag variables to make sure that the system performs as expected. The first thing I check in the while true block is whether the buzzer has started beeping. In the interrupt handler, the BZ start time would have been set to the time at which the buzzer was switched on. We want the buzzer to beep for 5 seconds. Here again, if I'd done this in the ISR itself, I would have to sleep for 5 seconds, which is a violation of the ISR rules. Observe here that there are some extra parameters for the if keyword. If you already know programming, then you already know the keywords and bar or. If you are new to programming, then these keywords have the same meaning as in English. When you have two conditional operators with the keyword AND, then the condition is said to be satisfied if and only if both the operators evaluate to true. If you use OR, then it is sufficient if even just one of the operators evaluate to true. In the while true block, I then check if FB reported is false. If it is false, then I set the doorbell state key in Firebase to on. I also set the flag back to false. By doing this, whenever the IR sensor detects an obstacle, the value is reported to Firebase only once. Instead of using the flag, if I had written to the cloud database in the ISR itself, then I would have violated one of the ISR rules, which is to return control to the processor very quickly. To address this rule, I set the flag variable in ISR and do the actual database operation here in the main loop. Note that I have created a function for setting the value in the DB. That is because we set the cloud database value in a few different places. In the function, we check for an exception when communicating with the remote database. If I had not used functions and done this operation directly in the code, I'd have to set the value in the cloud database and handle exceptions at every place where I need to set the value in the Firebase cloud database. Instead, I use functions and don't have to repeat the code. In this function, you can see that there's a new set of Python keywords: try and except. After completing this tutorial, I will explain about Python exceptions in a separate tutorial. I then check for the value of mode key in Firebase. If this value is set to force_on, then I turn on relay 1. Recall that the relay modules are low trigger relays and thus I have to set it to low to turn it on. If this value is set to force_off, then I turn off relay 1. If the mode is set to auto, then I call the function set_light_auto. The function checks the ambient light level using the LDR, and based on the light level, it either turns on or turns off relay 1. In all three modes, I write the current state of the light to the remote cloud database. If the mode is set to anything other than the above three values, then it prints out a message stating that the value for mode is unknown and also toggles the state of the onboard LED. I will not get into the details about how to make the connections. We've already seen this while connecting individual modules. In my setup, this is how the whole connections look like. So that's super. We just made our first project. I will leave it up to you to execute the project and see if everything works fine. Just remember to do the following before execution. In your Firebase database, create one entry for mode under a tree called touchless_entry. During your test, you can change this to different values like auto, force_on, force_off, and other values. See what happens. Just one note before I wrap up. In this tutorial, I have not connected the actual light to the relay. This is a task that you should take up when and only when you are comfortable working with AC. Live AC is extremely dangerous and can cause severe injury or even death. I have a separate video to demonstrate the use of relays with real devices. You can look that up for more information. That's amazing. We are now done with building our first IoT project using a Raspberry Pi Pico. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.